What's happening, guys? It's Ebune from Joe Digital Academy. So you might be wondered on why I'm taking C programming in 2020. Okay, so what actually happens is that I've noticed that many students that want to program in other languages like Java, C Sharp, PHP, and other languages that always have some difficulties in it. So you might know that those languages in which I mentioned, that is Java, C Sharp, and other languages that you're familiar with, started with C programming, which means they were built from C programming. So C programming is actually their parent, right? So that is why in 2020 we'll be talking about C programming. So let us dive directly into the course in detail, right? So let us talk about C programming. So I also noticed that most people don't really understand some core concepts in programming. That is why in this screencast, we'll be taking everything from the very basic right up to the very end. Okay, so let us move to the first thing. Now you'll notice that all programming languages that you know of are actually categorized into three main types. Okay, so there are actually three general languages that most programming languages actually are based on. So the first one is actually the machine language. That is what the computer actually understands, right? So we have the machine language, we have the assembly language, and the high level language. Okay, so these are the three main basic languages in which all other programs or all other programming languages like C Sharp, Java, ASP.NET, and whatsoever thing are actually categorized under. So let us take the first one, which is machine language, right? Now, the machine language is actually the natural language of the computer. Okay, it is a language, natural language of the computer, and everything that we write, right, is being considered as the object code. We do write the object code, right, which comes from the word object-oriented programming. Actually, comes from the word object-oriented programming, and the natural or the machine language, right, it consists of zeros and ones. Right, it's actually a language that actually consists of zeros and ones. Right now, when I say it consists of zeros and one, I don't mean that you write zeros and ones when programming, right? It is actually reduced to zeros and one, right? It's actually reduced to zeros and one. And within machine language, it is actually machine dependent. Okay, it is machine dependent, meaning that if I write a program, right, on my architecture, let's say I have a 64-bit operating system, right? And someone has an 86-bit operating system, that's 32-bit and 64-bit. So if somebody has it, if we have two different architectures, then my program might not be able to run on another person's program. That is why they say it is machine dependent, which means if I write a program, right, it's going to run only on this computer and might have some issues with other computer. So there was an issue with that. I decided we have to actually come up with the next language, right? Now, this is actually an example of a machine language code. So with this code, what we are doing is that we are taking a variable, we add it to another, and assign it to a different variable. So this is how programmers in those days, right, when they were writing the machine language, wrote their code, right? They wrote their code in this format. Now, with this implementation, you actually see that it is actually very slow to implement, right? It is slow to implement and very tedious for programmers. Okay, now it is very difficult for programmers to write it. Just think about it. If you're a programmer in those days, right, you need to write something like this, right, and it's very single mistake in one figure, right, will actually change the whole script. So it was difficult for programmers to actually understand. Now let us move directly to the next language, which is the assembly language code. Right, we have the assembly language. Now the assembly language came to replace or came to solve the problem of the machine language code. So with this, they made it in such a way that the assembly language was or actually had English-like abbreviations. Okay, it had English-like abbreviations, and these English-like abbreviations were termed as the assembly language. Right, so they named it. They had to come up with abbreviations on the machine code, then named it as an assembly language. Now, this assembly language actually has what they call the assembler. The assembler is what actually converts the assembly language code to the machine dependent code or the machine language code at machine or computer speed. Okay, actually convert that at computer speed. Now let us see an example of the very code in which we saw for the assembly language. You notice that in the assembly language, we say load base P, add over P, and store it in gross P. Okay, so that is what programmers actually did with the assembly language code. So they actually wrote this. Now this could be converted into a machine dependent code, right? So this will be converted to a machine dependent code, which is what we just saw in the last slide. So it's going to be converted that. Now all of these were actually named as the assembler, right? So all of this was being done by what we know as the assembler. Okay, so assembler actually converts the machine language code into the assembler actually converts the assembly language code, sorry, into the machine language code. Okay, now the next with this, you will notice that there are other things that were actually kind of, it was not really logical. Okay, now it was not really how can I put this? It was not, so they had to actually, with this there was still some lacks in it. So programmers came into a conclusion and see how they can actually come up with a language that is closer to the human language, right? So they actually named this as the high level language code, right? So we have the high level language, which is closer or closest to the human language. So with the high level code, it is actually English language and contains some mathematical expressions, right? So it is just English language and then contains some mathematical expressions. The speed in programming of this was actually increased. So there was an increase in the programming process of the high level language code, and statement with a single statement you can actually do substantial tasks with it. Okay, so with just a single statement you can actually do a bulk of things with it, rather than the machine language or the assembly language code where you want to implement something small, you need to actually write a huge lines of code. Excuse me. Now, with this, we actually had translation programs that could actually convert this high level language code into a machine language code, since the computer actually understands just ones and zero. Okay, the computer understands just one and zero. So they needed a way in which they can convert this high level language code, which means this English language, that it is this English language that has mathematical expressions that can be converted into ones and zeros. So with this, programmers actually came out with a translation program, and with this translation program they actually named it as a compiler. Okay, now a compiler, which actually does what, a compiler actually converts the high level language code into a machine language code, right? Actually converts a high level language code into the machine language code. Now this was actually kind of slow, right? It was actually kind of slow, so they actually had to come out with what they call an interpreter, right? Now they actually had to come out with an interpreter which actually had to execute high level code directly. Okay, now rather than converting from high level language code to assembly and to machine code, so they had to come up with an interpreter that actually will convert the high level language code directly to machine language code without any delay in compilation. Okay, so an example of a high level language code is this. So we see the base p plus overtime p, right? When you sum them up, you should assign it to the gross p. So that is what was done with that. Okay, now with all of this, let us actually get to brief history of how the C language was originated before we dive into the code. Okay, now but before going there, we have examples of high level language code. Okay, now examples of high level language code are codes or are languages in which you actually are familiar with, and the very first one is what we are talking about. So C programming, right, which is actually the first high level language code. Now with that we have C++, C sharp, Java, etc. Okay, now with that, let us go to the brief history of the C programming language, because we're actually based with C programming. Okay, now C was not actually, or is not actually the first language, right? It's not actually the first language that was developed. So before C, there was a language called B. okay, which was actually produced by Ken Thompson. So this was a guy that actually produced the B language. So B was actually used or created, right? It was actually created in the earlier to actually solve the earlier versions of the Unix operating system. So it was created for the earlier versions of the Unix operating system. Sorry about that. So it was created for the earlier version of the Unix operating system. Okay. Now, Ken Thompson actually created that in order for the operating system for that's for the Unix operating system. And with this B language, it was actually typeless, which means every data item occupied one word in memory. Okay, it was actually typeless, which means every data item will occupy one word um, um, in memory. Came now, my phone is disturbing. I just have to off it. Now, one word was actually done or was actually placed in memory. Okay. Now, the next with that, since with all of that issue, they actually had to come out with the C language. Right, the C language was formed. Right, with the C language was formed and developed by Dennis Ritchie. So Dennis Ritchie actually used the B language and had some with all the weaknesses with the B language, actually used it and came out with the C language. Okay. Now the C language was born, and with the C language, like we earlier said, it is mostly hardware dependent, which means when we write a code, it is based on our architecture, so it is hardware dependent. Now, with this brief history, let us actually get directly into our program development environment. How do you actually set up, or what are the phases in which the C language is being processed, which means from the beginning when we start writing the code right up to where the computer actually understands it. What are the processes in which we actually go through? Okay, now every C program passes through 6 phases. Now, these 6 phases what um, actually is being done inside the computer, which means what we actually do from writing our code right up to the ones and zeros that the computer actually understands. So what are the steps? So the first and primary step is that we need to actually write the code. So we need to write it inside an editor, right? An editor actually that's where we actually create and write our program. And we need editor programs like in this case we can use IDE programs like code blocks, dev C++ or whatsoever thing. Right, so we are going to get into this stage where we will be installing our IDE. Right, now we also need preprocessor. So from when we write our code, we have the preprocessor, which means C is actually a language that was built by others. So it was built by others and they have different libraries. So we need to actually process that library. Right? It actually has manipulations which are performed before every compilation. So that is it. We have and actually compile before any compilation. Now from there, from the preprocessor, once all of those library are being attached to our code that we wrote in the editor stage, right, we need to actually compile it. Now once we compile this code, right, it means we are trying to convert our high level language code into an object code. Right, we're trying to actually convert the high level language code into the object code, in which will actually be used by a linker, right, in which will actually be used by a linker to actually convert the object code and actually create an executable file. So the linker actually uses that object code that has been compiled, right, and converts it into an executable file. Now when it converts it to an executable file, we actually need a loader that actually loads this executable file in memory. Let's actually load this in memory. Now once this is loaded in memory, we have to actually execute the program. So the program gets executed and we see whatsoever thing that the programmer has always written. Now you might notice that most of these stages might not go very well. Right? There might be some errors in some stages. Now when we get errors in some of these stages, then we need to actually make sure that we follow the syntax rule or the language rules before doing whatsoever thing again. So we need to actually follow the language rules before doing that. Now, a lot of theory. Let us actually dive directly into the practical, and let's start installing our IDE. Right? I've been using IDE a lot. So IDE stands for Integrated Development Environment. That is where it actually integrates from the I so because normally what we can do is that you can actually download a separate editor, a separate compiler, and even a loader. Right? You can download all of that separately. But what we are going to do is that we are going to download an IDE which actually integrates all of those development environment. Right? That is why it's called an IDE. Right? Okay, so let's dive directly into that and see what we have to do. Okay.